This week on Cloud Slaw, we're going to learn about a mistake that led to millions of records being stolen and how not to make it. For those of you that ever heard about the big Capital One breach, did you ever wonder what the mechanism was? Like, how could that happen? And not all the individual details about that, but how could an attacker steal the role credentials for IAM from an exposed instance? Well, today's your lucky day. In our last lab, we explored static access keys inside of instance configuration files, that configuration file and the config file and the credentials file. But if you recall, in a number of labs, we've been using IAM roles instead, which is why I told you don't make IAM users, stay away from those AKIAs. And when we talked about roles, I said they are a temporary set of credentials for a session that AWS manages. Now, this makes life harder for attackers because credentials only last as long as the session is set for. And now it's time to learn just how that happens and how those credentials can be stolen from an instance if an attacker can get in. Roles came a long time after those static access keys, and Amazon realized it needed a more secure way to handle credentials since the very concept of access keys, which was originally just created for API calls for the root account, doesn't scale securely. But all the APIs rely on that built-in cryptography of access keys, and Amazon didn't want to break everything completely from how it worked, and it was a pretty good mechanism. They leave that to Microsoft. So instead of replacing access keys, they enhanced access keys when they created roles. When you assume a role for a session, or your instance will do it for you automatically, like we've been doing with that SSM client role, AWS provides an access key, a secret key, and a security token. All the API calls need all three of these elements, which are issued by something called the security token service that we call STS. Now, wait, didn't we see that in our IAM policies when we first created roles? That's right. The little STS : assume role permission, we sure did. That was the permission that would allow that entity to actually connect to the security token service to get the role's credentials. When you make the API call to assume a role, which means you're creating a session and you're asking for the permissions assigned to that role, STS will return an access key, a secret key, and a session token that are good for the life of the session. Default for most things is about an hour, but it can last longer or shorter. For instances, it lasts about 6 hours. You then use those to make your API calls instead of just the access key and the secret key alone. It's more secure since once the session expires, the STS issued access secret token combination no longer works. Want to see what these look like? Well, if you go into your Identity Center sign-in portal, you can click on the access key link instead of the console link, and it looks like this. Let's go to mine. So here I am, and if I go into my test account 1 and I click my down arrow for administrator access, I can just click access keys right here, and it provides me the access keys. And it's all this information about how to use those on the command line, but the key part is here that you have the access key ID, the secret access key ID, and also your session token. And so to make these API calls, you need all three of those to work together. So this example shows you how through Identity Center, you can assume you log into Identity Center and you are assuming your role, and you can still work on the command line by getting those credentials. Now, did you notice that access key started with ASIA instead of that evil AKIA we talked about last week? And that's the sign of the security token service at work. AKIA always means it's a static access key for an IAM user, and ASIA is a temporary access key that's issued from STS. When we create a role in the IAM part of the console, that we have the option of choose if it's going to be used by instances. And if we select that, it creates the role, which allows the EC2 service to assume that role. So this is how when you run an instance and you assign it a role, it's able to collect the credentials for that role. It does this through something called an instance profile. The instance profile is like the container for the role and acts as a bridge between the role and the EC2 instance. So when you launch an EC2 instance, you can specify the instance profile to associate with it, And you have to have an instance profile for an instance to assume a role. And in our case, we've been using that SSM client role all over the place so we could log in with Session Manager. This profile contains the IAM role you want the instance to assume. It's the bridge between the two. Now there's one more piece we need to make this work, and that's called the Instance Metadata Service, or IMDS. This is a special little network endpoint in every single VPC and always at the same address that an instance can query to get information about itself. At a basic level, this is how an instance can figure out things like its IP address, its own instance ID, and other important information, including things we're going to get to down the road. And since I'm really bad at block development, you already figured out that the IMDS is the thingy that talks to the IAM instance profile, which calls STS itself and holds the access secret token for you to use. And this is going to make a whole lot more sense once I show it in a diagram in a moment. So the way things work is if you log into the instance to use the command line, or you have an application that needs Amazon credentials, like to get data out of an S3 bucket, that little app or that command line will ask the metadata service for credentials. And if there is an instance profile within the metadata service associated with that instance, then it will do the assume role operation, the instance profile, and it gains the access key, the secret access key, and the session token from STS. Those are then available to read directly from the metadata service. And as I said last time, I think the session length is about 6 hours, and then the credentials are rotated. And so the entire process looks like this. Let's go to the whiteboard. And what we have here is I'll just have the whole process mapped out, and let me change the color of my pencil here so that we can make this diagram look a little bit nicer. Whoops, I selected the wrong thing. And there we go. Okay, so I'll use green for this since I don't have as much green on there. So when an application inside of our instance wants to make API calls, for example, to gain access to S3, it is going to make a request to the metadata service. When it asks the metadata service for its credentials, and remember, it doesn't need to know its role name or anything else. This is all handled. The metadata service then communicates with the instance profile, which does the assume role operation to the security token service. That returns those values, which get passed back into the metadata service and then back into the application. And the application now gets its access key, secret access key, and session token. So these are the 4 pieces you need to make this work. So 1 is you have to have an instance or an application trying to make that API call. 2, the metadata service, and that is always there. 3 is the instance profile. And now the instance profile is only going to exist if in the console or via your CloudFormation template or Terraform that you have actually assigned a role. And the instance profiles are one-to-one matched to specific roles. Then it's going to communicate to the security token service. So give me my credentials, metadata service goes okay, instance profile assumes the role, passes all of that back, and that's how it works. Now that's pretty cool. But how could this lead to the Capital One breach? Well, at the time of the breach, the metadata service had a weakness that was really well known by attackers. In fact, I used to have a lab in one of my training classes where we did this. All you needed to do was extract the information by going to a static URL. And I'll show it on the screen here, 169.254, 169.254, and then a string of like you're going down a directory path. And that will actually give you all of the security credentials. And if it makes sense, that's how it needs to work. The instance asks the metadata service for, give me my credentials so I can make my API calls. So what's the problem? Well, there's a kind of attack known as server-side request forgery. And a lot of software out there is vulnerable to server-side request forgery. Imagine you have a web server and it has this vulnerability and it has like an input field, like a text box in it. And all you need to do is like paste in the URL for the metadata service and it would return whatever the metadata service gave you. So you don't even need to hack into the server or anything. If the application is vulnerable to SSRF, you just find the place where it's vulnerable. And it's called server-side request forgery because you're putting in a URL in a place that tricks that server into making a connection like inside behind the firewall to that URL and then returning the results to you, the attacker out there on the internet. And this is really bad when it's all that juicy metadata stuff that we want. And so once the attacker gets that access key, secret key, and the token, they can kind of work from anywhere, including your laptop. Now, look, the cloud providers are kind of locking this down better in different ways. And I'll talk about the metadata service v2 in like a few seconds. But you can still, to this day, take an access key, a secret access key, and a token and use it from outside of Amazon unless there's other really more advanced defenses put in place. As a result of the Capital One breach, Amazon finally did what everybody was begging them to do and created version 2 of the instance metadata service. And this adds some complexity. You have to request a token, and how you actually make your request is not just going to a simple URL anymore. And we're going to see that in our lab today. And so that's what we're going to do. Our objective for our lab today is we're going to launch a couple instances. We're going to play with the metadata service, and we're going to see how to steal credentials. And please don't go try and hack a bank with this, because I'm giving you these super secret hacker skills that everybody knows. For the lab itself, we're going to launch a CloudFormation template that's nearly identical to the last one we used. That's just going to go ahead and launch an instance. By default, that's going to be on the metadata service version 2. Then I'm going to show you how to manually launch an instance with metadata service version 1. Now you might ask, why does anybody use that? It turns out, IMDS version 1 is still like used really extensively by people because they've coded a lot of stuff to rely on it. Then we're going to log into each of those. We're going to hit the metadata service, and you're going to learn the difference, and you're going to learn how to extract those credentials. All right. First, start with your sign-in portal, and we're going to do all of this in test account 1 and with our administrator access. Then we want to go into CloudFormation, and let me go get that URL from the blog post. Okay, got it. Let's go to create stack, existing template. You guys have done this a zillion times now. Click next. We'll give it the name. And this week, let's go IMDS. I don't know why I keep IMDb is in my head all the time because I'm a movie nerd. It's IMDS. And we'll scroll back and hit next, or scroll down and hit next. Scroll down, I acknowledge, and click submit. Okay, this will take just a couple of minutes to get up and running, so I'll pause until it's finished. Everything great is complete, so let's go back now to EC2. And the first thing we want to do is launch an instance. So we have one instance running right now, and as you could guess, this is using version 2 of the metadata service. But we do need one for version 1 as well. So let's go to launch instance, and the name of this instance will be IMDS v1. I think none of you doubt my lack of creativity at this point. And you can just leave all these defaults here, current version. But we do need a couple of settings we have to change. So the first one we want to change is the key pair, and we want to proceed without a key pair, again, because we're using Session Manager. Then for the network settings, we want to select an existing security group, and we'll just use our default. And that's the default one built in for the VPC. Again, this will be totally compatible with Session Manager. In case you're wondering, there's no NAT gateways or service endpoints because we just put everything in a public subnet. But with the security group rule in place, that still there's no way for the internet to reach it. Now, here's the important part. We have to go to advanced details. There are 2 settings we need to change here. The first is IAM instance profile, and we need to give it our SSM client 1 so we can log in. Then we're going to scroll way past all sorts of other stuff here, and it's easy to see it because you're going to have this yellow block. It's metadata version, and we're going to go V1 and V2. V2 is always there. V1 is only available. Now, if you turn on, now you'll notice that even years, so that was what, 2019 or something was the Capital One breach, or maybe earlier, and we're, still having both versions of the metadata service. Amazon really doesn't like to deprecate stuff very frequently. So it would break a lot of things if they got rid of it. Then we're going to go to just launch instance. Okay, it's going to take a few minutes for that instance to be available. So once you hit this screen, go to instances, and we're going to let that thing boot up. Now you can see, let me change mine to just show only the running because I was doing some testing before. And then I'm going to hit refresh. And there we go. I have 1 and 2. One is the state is pending. I want to give it a little bit longer, so I'm going to pause. Oh, now it's running. I'm going to pause, though, for about 30 seconds just to make sure it's truly booted up. Actually, I'm not going to. Yeah, let's do that. That was just about 30 seconds just to make sure. Let's hit a refresh, see if I have my status checks. So still initializing, but let's see if we can log in. So I'm going to go click the box and click connect. We'll go to session manager. Everything looks good, and connect. Now, once session manager is up and running, I've got my command line prompt. What we want to do is see how we can get our credentials using version 1 of the instance metadata service. All the command lines you need are in the blog post. Now, the first thing is, let's imagine we're an attacker that gained access, or I'm coming in through SSRF. I have no idea what the name of a role is or what role is assigned to this particular instance, what instance profile is in use. So let me pause. I'm going to go get that command line. And my second command line is, whoops, it pasted it improperly. Let me go ahead and clear this out. And so my second command line, and then SSM client. And there we go. Look how easy that was. I have my access key, I have my secret access key, and I have my security token. And the way this environment is set up right now, I could take these, I could run them from my laptop, and I would be able to make a connection in. Oh, and you actually get to see the expiration date there. I don't feel like doing the math to see how far away in the future that is. Hopefully it's at 6 hours. This is version 1 of the instance metadata service. And it's really easy if you log into something, or to actually, you can see these are just URLs that we used. It was 2 URLs that gave me the name of the instance profile and then would give me all of the credentials. Super easy to do. And this is enabled if you have one of those SSRF vulnerabilities. You could potentially just get this by typing things into a web server, any old page on the internet that's running in AWS that has that vulnerability in it. All right, so let's go back to our console and let's close this one out. And let me reset this again. You can see I'm still zoomed in from my trying to make that screen a little bit better. Let's check out V2. So click on it, click connect, session manager. Now, these have the same role name, so I'm just going to paste in the same command line as before. And if I hit enter, you'll notice I get no results back. Nothing. That's because this is a different process with version 2. So I'm going to go grab those command lines and we'll enter those in. The first thing we need to do is get a token. So token equals, and now we're using the curl command again. But in this time, it has to use a put. That's a HTML thing. And it's going to the metadata service latest, but not going to the metadata service. It's going to API token, and it's requesting a token with a particular timeout. Again, I can't do the math. I used to remember what the 21,600 meant. Maybe it's an hour. No, I think it's a lot more than that. So let me hit enter. So now I have gone and gotten that token. Now, this is defined as a variable called token. It'll make sense why I did it that way in a minute. All right, let me go get my next command line. This command line is going to get my role name. So get my role name by using that curl command again, but you'll notice I have to provide the token. That token is bound to this specific instance. The token won't work anyplace else. So you have to have the valid token, and it has to come from the instance that created it. And it's 169.254. Now I'm able to go to the metadata service. Oops, I accidentally clicked on that. Ignore that, and let me hit enter. That was my shift key. Let me hit my enter key. So now the token is in memory and the role name is in memory. Let's go retrieve our security credentials. Paste in the next command line. Again, I still have to have the header. I still have to provide the token. And then so I'm providing that token value in the header and then all the other information in the role name. And this time it will give me the credentials just like before with my ASIA, my secret access key, and my token. Why does this work? Why does this stop SSRF? It has to do with how those vulnerabilities occur in those web servers. So look, if somebody hacks into the instance, they can still run these command lines. They can pull everything down. And there's all sorts of toolkits and automation to grab those if they get on the instance. But this protects us from those attacks, like if this is set up as a web server and somebody is able to come in and try to trick it into providing results. Not just web servers, API servers. There's lots of stuff where this could happen. And that won't work anymore because the nature of using those put commands in and getting that token and then having to provide those headers, that adds enough roadblocks that it breaks the ability to do SSRF. And I'm not going to get into all the nitty gritty details about that. Heck, half the time I confuse myself between get versus push or put and all the HTML or HTTP stuff. But that's what you need to know. Version 2 of the metadata service must be your baseline because it will stop SSRF, because the attacker is not going to be able to use that token and manipulate things and pull that data into the outside. Version 1 of the metadata service is really easy to break. And most of the modern tools and stuff we use, modern as in from the last 2-3 years, are now working with version 2 of the metadata service. You might still have stuff with version 1, and any of you working in a large environment, I know version 1 is still there. The default is not to use version 1, so you're probably wondering why I spent so much time on this, but it still is a pretty endemic problem in a lot of places. You're going to encounter it, and you might find developers, or you might even find software packages that will only work with version 1 of the metadata service, and that's going to be a problem, and you want to make sure you don't use those. Only use version 2. Don't let anybody use version 1. And heck, I think you can even block that with things like IAM and service control policies. All right, lab itself is pretty quick. Hopefully this showed you how all this came together. And yeah, this is part of what happened in the Capital One breach. They had something exposed that had an SSRF vulnerability. The attacker was able to use that using version 1 of the metadata service, extracted the credentials, and then from an environment under her own control, she's able to do all sorts of API calls and get into S3 buckets and expose that data. More to it than that, but this covers the basics. This is why we have version 2 of the metadata service. That incident led to broad changes. Hope you got something out of this. See you next week.